Okay, so two ships leave a harbor at the same time. That means we have to start with a harbor. So we put our harbor here. We'll label that H. We may have to move that H. We'll see what happens. One ship travels on a bearing of south 15 degrees west. So because this bearing is given from the southern direction to the western direction, I'm going to draw. Actually, I'll probably just do this because I know I'm going to have this other bearing in a second. The bottom line is you need to have a north-south line because that's how this bearing starts from south, swinging to the west 15 degrees. So I'm going to take another line here. So this is the direction of the boat, the angle that I form with this line and due south. So I'm forming an angle with south, swinging to the west 15 degrees. This is probably a little bit bigger than 15 degrees, but I don't want my drawing to look too complicated. So that's a 15-degree angle right there. Okay. It's traveling at 17 miles per hour. Now, just because I know where this is headed, let's address this right now. If it travels for 17 miles per hour and it travels for 3 hours, that means it's gone a total distance of 51 miles. So the length of this segment is 51 miles. This is where the boat is. We'll call that boat A. Okay. Traveling in this direction for a total of 51 miles. The other boat is traveling on a bearing of north 75 degrees east. So we have to use due north from the harbor, and we have to create an angle towards the east that's 75 degrees. So a 75-degree angle is almost nearly 90 degrees. So I'm going to make a rather big angle here. So this angle is 75 degrees. And here's the other boat. We'll call that boat B. Okay. The question, 9 miles per hour for 3 hours means this boat traveled a distance of 27 miles. And at this time, they want to know what's the distance between these two boats. So we have our we have our triangle drawn out here. Now, with respect to this triangle, there's 4 scenarios that we looked at when you know information about a triangle, some combination of sides and angles, right? These are the 4 different combinations: angle, 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 side, side, angle, side. Okay, we know that with this information, if we start with that, we're using the law of sines. And we know if we start with this, we're using the law of cosines. So when you look at the triangle, we know this is a side length with 51 degrees. So we have a side. We know we have this side length with a length of 27 degrees. So we have 2 sides, right? And when you look up here and you say, well, which one of these is setting up with the information we have so far, we're definitely looking at a law of cosines question, right? So what do we need, right? In between these 2 sides, we either need the angle or another side. Well, this is the side that we're solving for, okay? And we're going to call that lowercase h because it's across from angle h. So with the information that we know, these 2 sides, obviously we need to know what the measure of this angle is between them. And that's this entire angle right here. Okay. Try and draw that as best as I can. When you look at what we know this piece of that angle. That's only part of it, right? We don't have this other piece in here. We know that from south to this spot is 15 degrees, but we want to know what this piece is in here. And so I'm going to draw that angle. Let's see, do I have any colors left? I suppose I could do it in blue. So we need the measurement of this angle right here. Because if we know that, then we'll have the other piece to this entire angle. It just so happens that this angle here is formed with this north-south line. So if we continue that line up, we see this 75-degree angle. We haven't even talked about that. That 75-degree angle is not a part of the triangle, right? Obviously. But it does form a linear pair with this blue angle right here. And linear pairs, we talked about this in class. What's the angle measurement of a straight line, right? If we look at this as a vertex, is 180 degrees. If I take that 180 degrees and I draw a line off of it, like that, it's still 180 degrees. It's just that this angle and this angle have to add to be 180 degrees. Well, we have a 75-degree angle right here. So that means this piece of this angle is 105, because 105 and 75 makes 180. So when you combine the purple piece and the blue piece, we have an angle that goes 120 degrees. So now for the triangle that we have, and I'm just going to draw this over here real quick because it's kind of got a lot going on there. This is 27, this is 51, and we just found out that this is 120 degrees. So that's side angle side. If you want to know what this side length is over here, we set up a log cosines problem because the angle is 120, right? So we know that this is the cosine of 120, and then we fill in the rest. 51 squared plus 27 squared minus 2 times 51 times 27. And when you look at this, you can type all of that into your calculator and then take the square root, right? Good luck.